A polling organization surveys a random sample of 1,000 voters to estimate the proportion who support a new educational policy. Found out that 68% of the people support this policy. There's a standard deviation of 0.2. Now, from 100 simulations that each sampled 1,000 people, so these simulations basically replicate, what we're doing IRL. The sample proportions have a mean of 0.2 and a standard deviation of 0.015. Using this information, construct a 95% confidence interval for the true proportion of voters who support the policy. Now, one thing you might notice is that when we're actually surveyed, so when this polling organization surveys a random sample of 1,000 voters, notice how it gets a standard deviation of 0.2, which is much greater than the standard deviation of our simulations, right? The standard deviation for our simulations is way less than the standard deviation of 0.2. And that kind of makes sense because in these simulations, we're doing 100 simulations. So, the thing to know is that sort of the more data that we have, well, then that's going to lead to a smaller standard deviation, or it's also known as standard error. That kind of makes sense, right? Think about it. If you just kind of ask 10 people, Trump or Kamala. Now, I'm not trying to get political here, okay? I'm not trying to get political. But let's say those 10 people support Trump. Does that mean that 100% of our population supports Trump? No, right? And, if we sampled more and more people, right, we got more and more information, well, we'll find out that, it's closer to 50-50, right? It's closer to 50-50. Let's find out how to construct a 95% confidence interval. So what you're going to do is you're going to use the data from the simulations, because that's kind of like that's the data that kind of most accurately represents our true population, right? What they think. Interval, right? It's going to be an interval. So it's going to be kind of between two values. So what we're going to do is we're going to take our mean. It's going to be plus or minus z star. And then this is going to be multiplied by our standard deviation. All right. So what is our mean? Our mean is 0.62. This is going to be plus or minus now z star. What the hell is this? Well, z star changes based off of your confidence interval. So if I were to find out, in this case, I want to find out a 95% confidence interval. So z star in this case would be 2. Because within 2 standard deviations, it contains 95% of the data. If, for example, I wanted to find out, let's say if I wanted to find out a 90% confidence interval, then what I would do is I would use the z star value for that is approximately 1.645, I'm pretty sure. But, the point is that this z star value basically depends on, what percent confidence interval you want to do. And in this case, if you want to find out a 95% confidence interval, just use 2. It's approximately 2. And it's going to be multiplied by your standard deviation, which is 0.015. And what is that going to give you? It's going to be 0.65. And if we convert these into percentages, now what does this interval tell us? Well, it just basically tells us that we are 95% confident that the true amount of people in our population that support this new educational policy is going to be in between 59% to 65%. It could be 61% of people who, support this policy. It's likely that, 62% of people that support this policy, right? We're 95% sure that, the true population proportion is in between these two. Remember that anything outside of this interval is not likely. So, 58%. If I somehow got that 58% of kind of the population supports this new educational policy, in the context of my 95% confidence interval, that's not likely.